Please unmute yourself. Vishwajit, am I audible to you?
Yes, sir.
On your video, man. So, we are going to start the class, and as I said, now from last week we are giving a revision, a quick revision of a chapter solving all the previous year questions that comes in the board examination. So, last Monday, if you remember, we did for the first chapter where I gave you a quick glance. I am not deriving much because time is not there for that to do, but I am giving you a quick glance about how the questions are, like what are the topics and how the question comes from each topic. For example, in the last class, I have taken last 5 years paper questions only, 2019, 20, 21, 22, 23, 24, 25, that too in that COVID was there in between. So, we had very less exams, like they divided in 2 parts. So, whatever questions have come recently in last 5 years, I am focusing on that in this classes, last class onwards. Today is the chance of the second chapter, which is electrostatic potential and capacitance. Now, we are going to learn some concepts of this chapter. I am going to give a quick recap about that, and then from each topic how the question is coming in the board examination, I am going to talk about that. Okay. Manoranjan, you are in 11th, right? Which class you have joined? You want to learn 12th topic?
Sir, today it is Tuesday, you must have classes, right?
Today is which day, man? What is the day today? Monday, right?
Oh, sorry,
Oh,
sir.
you thought it is Tuesday? Okay, man. If you if you want to learn 12th topic in advance, you can learn. I don't mind. But if you won't understand anything, you can drop off, man.
Yes, sir.
Okay. Yes.
Sorry, sir.
Yes. No issues. So coming back. So in this chapter, the first topic, I am going to enter into the subject directly. We don't have much time. Big chapter. This is very big chapter. One of the biggest chapter of 12th is this after array optics, electrostatic potential and capacitance. And the first topic that is there in this chapter is what is electric potential? Anybody remembers what is electric potential? Anybody? Please be interactive, just not me talking. Whatever you know, you tell me. What is potential? You have book in your hand, man. What is potential? Huh? Object. Okay, very good. Charge from? It is the work done per unit charge, very important. If it is work done, it is not potential, it is potential energy. It is the work done per unit charge to move it from infinite to that point. When I say infinite, don't imagine something out of the universe. Infinite means very far, that's all. So, how much is the work done per unit charge to move it from infinite to a given point is called as electric potential of that point. So, whatever charge you have, it will have some potential. For example, 10 coulomb charge you have. If I go 2 meter away from it, what is the electric potential of this point? Conceptually, it is how much work is done to bring a unit positive test charge from infinite to this point. Suppose it is r distance away, then r distance away. That is known as the electric potential of this point. Always remember this, electric potential is work done per unit charge to bring it from infinite to that point. Many children will write in the examination work done to bring a charge, like how you told now, Shiva Prakash. They will lose marks in this, because if it is work done, it is potential energy. It is not work done, it is work done per unit charge. Work done is in joules, charge is in coulomb. So, SI unit of electric potential is joule per coulomb. It is also called as, what it is called as? Volts. Joule per coulomb is also called as volts. Yuvanesh and Sanghavi, your video must be on if you are joining for the online class, please, or else you have to come to the center. Video should not be off. Yes, coming back. What is potential difference then? Potential difference is always for 2 points. That is, if I take a point here and if I take a point here, this will have a different potential, this will have a different potential. Suppose this is R1 distance, R2 distance, point A and point B. Then potential difference is work done per unit charge to move it from where to where? From A to B, from 2 finite distances. So, what is the work done per unit charge to move a test charge between 2 finite distances is called as potential difference between the 2 points. And electric potential is the work done per unit charge to move it from infinite to that point. I hope you are clear in this. They are different only in this terms theoretically. Numerically, it also has the same formula. What formula? Work done per unit charge. And once again, same unit and same dimensions, joule per coulomb. Always remember, electric potential and potential difference are what quantities? Scalar quantities. They don't have any direction. Unlike electric field and electric force, which had directions, electric potential will not have any direction, and that is the reason we will consider minus q and plus q very carefully. I told you in the previous chapter, if you have charges plus q, then when you are finding the forces, we don't consider negative sign, isn't it? Because negative sign we use for finding the direction. But in the case of electric potential, if you have plus q, it will be minus q also will be considered. Please pay attention. I will come to that, some numerical that I will explain you. But in electric potential, the negative sign of a charge is considered in the numerical part, whereas in electric field or electric force, we never take negative sign. We just take negative for direction finding, right? So, I hope you are clear in what is the meaning of electric potential and what is the meaning of electric potential difference. Both are mathematically same, but conceptually a bit difference is there. Next comes, what is the electric potential due to a point charge? Sometimes, very rarely, I have not seen last 5 years, this derivation comes in examination, very rarely, but it may come. Derive the electric potential due to a point charge. If it comes, I will just give the steps to you, I will not do now, it will take time. So what you should do, you should take a charge q, and they are asking you to find at r distance away from it, what is the value of potential. You know the answer already. What is the answer? V is equal to kq by r. Good. Kq by r is the electric potential due to a point charge. But the derivation comes, how the derivation has to be done. If I remind you, what we will do, we will take a point here, x distance away from it, we will take a point x distance away from it, and we will find how much is the work done to bring a charge from infinite to this point. And then we will take dx as a small distance to move. We know that this charge q, on this q naught will be giving a force in this direction, isn't it? If it is unit positive charge and this is q, this q will be repelling q naught, and you will have F force in this direction, and dx is in this direction. We will find work done. Work done will become equal to F dx cos 180, and F will become equal to k q naught by x square. Then you will do work done is equal to integral of F dx, integral of F dx cos obviously 180 in this case. And when you do that, and then put the limit from where to where? From infinite to r, then you get the work done. Once you get the work done, you know that electric potential is defined as work done per unit charge. We will put the value of q naught, we will get the answer as kq by r. And while deriving this, you will get the value of work done as kq naught by r. This is only called as electric potential energy. We will learn in the upcoming topic today. But electric potential energy is defined as kq naught by r, whereas electric potential is defined as kq by r. The difference between them, I hope you are understanding. And this derivation is sometimes coming, very rarely coming, but you should not, if you are aiming for 100 marks, you cannot miss it. Study this derivation also and go. But the formula is very, very important, that is kq by r. So for any point charge, the electric potential value is kq by r. If there are multiple charges, one charge here, one charge here, one charge here. If I ask you, what is the potential at this point? Suppose here it is q, here it is minus q, and here it is plus 2q. There are three charges, q, minus q, plus 2q, and they are asking at this distance. Suppose this distance is r1, this distance is r2, and this distance is r3, and this distance is r4, and this distance is r5. They won't give you, sometimes they have to find all these distances. And if I ask you what is the electric potential at this point, what will be the answer? It will be kq by r5 plus k minus q by r3 plus k plus 2q by r4. Are you understanding? The potential at V will become equal to k into q by r5 plus k into minus q by r3 plus k into 2q by r4. So what I have done? I have just found kq by r considering the negative sign and positive sign, nothing else. When you put all these values, you will get the answer. Are you understanding what I am trying to tell you? this kind of questions are coming. I will show you how the question has come in the board examination also. So coming to the next thing. Yes, again next topic, relationship between electric field and electric potential. Anybody remembers relationship? Vishwajit, your video has to be on here. How many times shall I say that? Coming back, yes. So what is the relationship between electric field and electric potential? Very, very, very important. E is equal to negative gradient of electric potential. E is equal to minus dV by dr. Very important. We can also write this as, I mean in scalar terms we can write electric field is electric potential divided by distance, isn't it? I have said this to you, this is very important because it comes till the last chapter. Whenever we have talked about potential barrier and semiconductors, there also we have used this. So electric field and electric potential relation, which is negative gradient of electric potential, is very, very, very important. I even explained you what is the meaning of this. It means that electric field will always be in a direction of decreasing potential. Wherever the potential is decreasing, only that is the direction of electric field. That's why if you have a plus Q charge, if you go this point, if you go this point, if you go this point, it keeps on reducing. Electric potential is KQ by R1, KQ by R2, KQ by R3. R3 is the biggest, so it will have the lowest value of potential. R1 is lowest, it will have the biggest value of potential. So this is the direction in which the electric potential is reducing. That's why we put the electric field sign as radially outwards line, because that represents direction in which electric potential is reducing. That's what this equation says, that electric field will be always in a direction where electric potential is keep on reducing. Like for example, I told you minus charge, if you take minus Q, if I take R1 distance, if I take R2 distance, if I take R3 distance, you will find R3 will have a bigger value because negative charge, no, minus KQ by R. R2 will have a smaller value, R1 will have the least value. So the direction of electric field will be towards it. That's why for a negative charge we draw electric field into that is radially inwards. Important, okay? That's how the relationship between electric field and electric potential. Derivation of this also is there. I have taught in the class to you. Now I am not doing it, I will recall it for you. How we will derive? It's very similar to that. We will take a point, that we will take 2 points, point A and point B for existing charge Q, and we will find what is the potential at B. And this point will have a potential, suppose this potential at B is V, potential at B is V, then the potential at A will become equal to V plus dV, isn't it? V plus dV. Do you agree with me? Why it is V plus dV? Because it is more nearer to it. If it is more nearer to it, it has a more stronger potential. We will find the work done, and after finding the work done, you will equate with the work done equal to potential by Q naught, and you will equate both, you will get the answer as E is equal to minus dV by dr. Check your notes, I have derived already in the class. I cannot spend time on doing all these things now, because my aim is to take many questions today. Next topic in this chapter is electric potential due to a charged spherical shell. So during charged spherical shell, we have found the electric field. What is the value of electric field? Electric field is 0 inside the shell. Outside the shell, the value of electric field is how much? K Q by R square, if this is R. If you take radius as R, then the value of electric field is K Q by R square, and at point inside, electric field is 0. Am I right? So electric field outside the shell is KQ by R square, where R is the distance of the point from the center of this sphere, and electric field due to charged spherical shell on its surface will be KQ by R square, where R is the radius of the sphere, and inside the shell electric field is 0. I have taught this to you in the previous class, and you remember this also. Then we know that electric field is negative gradient minus of dV by dr. So at all the points where the electric field is 0, electric potential must be a constant, because differentiation of constant only is 0, isn't it? It means that if I take this point and I write what is its potential, I will write the potential at this point is V is equal to K Q by R. If I write the potential at this point, V will become equal to K Q by capital R. But if I write the potential at inside, it will not be 0. It will be also equal to K Q by R. That is very important. Electric potential inside a shell is 0, electric field inside a shell is 0, but electric potential inside the shell is not 0, is non-zero. So if I draw the graph based questions are coming in the board examination, where if I draw the graph between electric potential and distance x, the graph is like this, isn't it? That is, up to the value of radius becomes r is equal to r, the electric potential remains constant, and then it starts to decrease. Whereas if you remember the graph I have drawn in the previous class, electric field will be 0 and start reducing like this. Up to r is equal to r, electric field is 0. This is the graph between electric field and distance. One more kind of graph is there, that is for actually volume charge density. So we will get confused in that. Sometimes question may come like, there is a charge, there is a shell which is having charge such that it is spread across its volume. That is volume charge distribution like this. And then they will ask you to draw the graph between its center towards outside for electric field. You should not draw this, because if you have charges fully filled inside the shell, then how will the graph be, like this and this. Have you seen this question? It has come in the mock tests. I don't know how many of you know this question. Up to this point, electric field, that is R is equal to R, electric field will constantly increase, and after that electric field starts to reduce. This is the graph for volume charge density between electric field and distance. These three graphical kinds of question comes from spherical charged spherical shell. One is electric field versus distance for charged spherical shell, electric potential versus distance for a charged spherical shell, and electric field versus distance for a charged spherical shell with volume charge distribution. I have seen many children drawing this graph. Drawing means what? It comes in MCQ. The answer will be this, you will take this and come in the examination. So please be careful about that question, because I have given this question in the mock paper, I think. Up to now, if you are not got, you will get in the future. Okay. Next, we will go to the question. Now, start solving this question, guys. This is the question from the last year paper, board paper. Last year board paper, question was there. Two charged conducting spheres of radii A and B are connected to each other by a wire. Find the ratio of the electric fields at their surfaces. Searching the question where last year it came, finding the answer for it.
No, sir, no answer.
Only question is there. Okay. But there is no use of searching the question now. Solve. I have questions there on the board here. See and try to solve. Give a try. Give a try. Everybody, please give a try. Good question. This is not simple question. 3 mark question it was. In board it came in 3 mark category. I hope you are solving. I'll give 2 minutes, please solve. Are connected by a wire. Why you touched it? I hope you are solving. Any answer? Tell man, give a try. Sanjay, tell me. Oh, doing. Try. It has come in past board. This is the level of question expected in the examination. Any answer? Okay, let me ask this question to you. If there are two shells and if they are connected, what will become same between them? Charge. If there are two charged shells, two charged conducting spheres of radius A and B, if they are connected by a wire, what will become equal? They will have different potentials initially, but slowly as the redistribution of charge takes place, their potentials will become same. Are you knowing this? If you are not knowing, know it today. That when two charged spherical shell are coming in contact, that is when they are connected together, redistribution of charge takes place, which leads to same potential of both the shells. So it will become V1 is equal to V2. Now what is V1 formula for a shell? KQ by R. So it will become KQ by A, and this will become KQ by B. Can I write like this? Or I can write KQ1 and here I can write KQ2. KK gets cancelled. You will get the value of Q1 by Q2 is equal to A by B. But they are not asking you to find the value of Q1 by Q2. They are asking you to find the ratio of their electric field at a surface. That formula also we have. What is the formula of electric field? Electric field at surface E1 will become equal to KQ by Q1 by R1 square. And what is electric field for second? KQ2 by R2 square. Now it became simple because here they are asking you to find the value of E1 by E2 and KK will get cancelled. It will become Q1 by R1 square into R2 square by Q2. Now what is Q1? By Q1 by Q2 is given as A by B. We have found it actually, A by B. And what is R2 by R1? R2 is how much here? B. So it will be B square by what is R1? A square. So this B will cancel this B, A will cancel this A. Answer is B by A. So E1 by E2 is equal to B by A. Again, I think out of 100 people, only 10 will write this question correctly and come in the board examination. 90 will make mistake in board exam. Simple question it is, but then also many will do mistake in this. When I solved it, did it look very simple? What I have done? Just we have equated, got Q1 by Q2 and electric field I have found and found the ratio. That's all I have done, nothing big I have done. 3-mark question in board examination. Any doubt? Can I proceed to the next question? Can I go to the next question, guys? If you allow me. Yes, next question. At least I have a 2-mark question this is. 2 mark once again in 2000 last year compartment paper. This question was there in last year. Again a very good question. Try. Last year compartment paper, this question was there. A uniform electric field E of 500 Newton per Coulomb is directed along positive x-axis. O, B and A are 3 points in the field having x and y coordinates 0, 0, 4, 0 and 3, 0, 3. Calculate potential difference between O and A and potential difference between O and B. Give a try. Sangvi, you are doing, no? Unmute yourself and say yes or no. Are you there in class, Sangvi? If you are there, just say yes or no. Yuvan, Yuvanesh, solving? Vishwajit, I hope you are solving this question. So, even if you fail and write compartment examination, you are going to get this level of question. Actually, it is again simple question, but previous question also was simple only. department waiting. When you will solve, I will just copy. Give a try at least. Shall I give you a hint? Draw a diagram. They have given the coordinates, no? Draw the diagram, everything will be easy. Now you are getting the answer, anything? Tarun, you have drawn something. Any idea you are getting? Electric field you have not drawn, it is in positive x direction, right? Electric field you have not drawn, it is along positive x direction. So, what will be the potential of point O and A? See, they have told electric field is there like this, and they have told electric field value how much? 500 Newton per Coulomb, right? And they have given 3 points. If I am just taking the axis in this itself, then one point is what comma what? 0 comma 0, that is origin. What is this point? This point is O. Second point is B, which is 4 comma 0, somewhere here, right? 4 comma 0. This is point B. And third point is C, not C, A. This point is 0 comma 3. Don't you feel that 0 comma 0 and 0 comma 3, they are lying at the same points in the electric field? What is equipotential surface? I have not talked about that till now. I will go that is in the next slide. What is equipotential surface? It is a surface joined by, it is a surface formed by joining all the points of same potential. I have told you, electric potential is always perpendicular to electric field. You know this? So, can you see this line is perpendicular to electric field? It must be a equipotential surface. And if so, point O and point A will have same potential. If the point O and point A will have same potential, what is the potential difference between them? 0 for the first part. Are you getting why I am saying it is 0? Because it is equipotential surface. Now, how the surface become equipotential? How I am saying this? Because point 0 comma 0 and point 0 comma 3 are lying on a plane that is perpendicular to electric field. And you know, a plane which is perpendicular to electric field must be equipotential surface. But can I say for the second part also answer is 0? No. You have to solve this. How will you find potential difference? You will find the potential at A. Again, how will you find potential at O and B? Potential at O, we know it is 0. Potential at B, how will you find? Minus dV by dA, right? Electric field is equal to minus dV by dr. So, what will be electric potential? Electric potential will become equal to 500 into distance is how much? 4. How much is that? Negative of, actually 4 centimeter or meter. Centimeters, how much it will be? Negative of 500 into 0.04, isn't it? So, how much will be that? Minus 20 volt. And what is the potential of this point? 0 volt. What is the potential difference between them? Minus 20, 0 minus minus 20 will become 20 volt. So, the answer for the second part is how much? 20 volt. And what is the answer for this point? 0. Got it? Why the answer is 20 for the second part? Because we found the potential of O, we found the potential of B, and we subtracted both, we got the potential difference as 20. 0 minus minus 20 will become 20, or minus 20 minus 0 will become minus 20. It does not have much meaning of, because electric potential cannot have negative magnitude. So, it is just the direction of electric field that is being represented here. So, are you clear how the answer came as 20? Are you clear how the answer came as 20? And I hope you are clear how the answer came as 0 for the previous part. Got how the question can come? See, I am not taking all the questions. I am taking the questions which are little challenging and which can give you an idea about how you should study for the board examination. So, you cannot predict questions in the board exam. It will be suddenly coming newly. If your concept is not clear, you will have struggles only. Next question, fast, again a good question. Two small conducting balls A and B of radius R1 and R2 have charges Q1 and Q2 respectively. They are connected by a wire. Obtain the expression for charges on A and B in equilibrium. Again, a 23 question. And how much marks? 3 mark again. It's a 3-mark question. Two small conducting balls A and B of radius R1 and R2 have charges Q1 and Q2 respectively. They are connected by a wire. Obtain the expression for charges on A and B in equilibrium. Give a try, give a try. Any answer? Don't say Q1 by Q2 will become equal to R1 by R2. That only you got, no? 3-mark question, man. Moreover, they have not mentioned very clearly that Q1 and Q2 are the charge on the surface. In the previous question, they gave spherical shell. Here, they have not mentioned anything spherical shell. They just told that two small conducting balls. So, one ball is there whose radius is R1 having a charge of how much? Q1. And there is another ball having radius of R2 having charge Q2. But one thing we can find, if we are assuming, actually we can find in terms of sigma also, or we can find in terms of rho also. For this question, if I see the answer key given by the board exam, board will give answer key, right? Marking scheme. Marking scheme, some students have solved by sigma and some students have solved by rho. For both they are giving marks. Rho means volume charge density and sigma means, sigma is linear, surface charge density. So, can I say in this case sigma 1 will become equal to Q1 by 4 pi R1 square, can I say like this? And what will be sigma 2? Sigma is Q by A. So, sigma 2 will become equal to Q2 by 4 pi R2 square. Do you agree? Then, can I write what is the value of Q1? Q1 will become equal to sigma 1 into 4 pi R1 square and Q2 will become equal to sigma 2 into 4 pi R2 square. Why we are cancelling when we are not dividing anything? If you divide, we will not dividing. Why? Because they have told these two are connected after that. So when they are connected, then what is the total charge now? Total charge will become equal to Q1 plus Q2. Do you agree? Charge Q1 and charge Q2 on both the spheres, when they are connected, the total charge will become Q1 plus Q2. And what will be its value? Q1 we know, Q2 you know. Sigma 1 into 4 pi R1 square plus sigma 2 into 4 pi R2 square. So if you take the value of 4 pi common, it will become sigma 1 R1 square plus sigma 2 R2 square. This is just the value of Q. And what will be the sigma now for the whole, both the shells? It will become total charge Q by total area A. Total charge value we have, total charge value is 4 pi into sigma 1 R1 square plus sigma 2 R2 square divided by what is area? Area will become 4 pi R1 square plus R2 square. If I cancel 4 pi, I am going to get the total sigma as sigma will become equal to sigma 1 R1 square plus sigma 2 R2 square by R1 square plus R2 square. Do you agree? See how the question is. Now, not over yet. Sigma alone you have got. Now they are asking you to find the expression for charges on A and B. Charge on A will become equal to Q1 and that will become equal to sigma 1 into A, isn't it? Not sigma 1, sigma into A. Sigma into A1, the first area. Now sigma value we have, if you multiply with what? This A1, area will become 4 pi R1 square, then you get the value of Q1 and Q2 will become equal to sigma into A2. That's how you should solve. It's a challenging question. Little bit. Again 3 mark, you have to work. Still not understanding? Then you have to practice after the class. Today, understand this chapter can be troublesome and this chapter has more weightage in the board examination. Okay. So, I have found the value of sigma 1 and sigma 2 for both the balls, and then what I have done? I have connected them. I have found total charge. Total area will become equal to 4 pi R1 square plus 4 pi R2 square, and then we have found the value of sigma of the whole combination, and then when you multiply the sigma value, that is charge density, it is charge per unit area, with what is the area of the first shell, you will be getting the charge on the first ball, because they are asking in equilibrium. That's why all this tension is there. Otherwise, charge on the first shell you can say sigma 1 4 pi R1 square itself over. But they are saying after they are connected, what will happen? Then it will change. The Q1 will not remain in this one. Q1 will become something Q1 dash. It will become Q1 dash and it will become Q2 dash. How much is the value? Solve and get the answer. Got it? Got it? This is the way the questions are coming. Next we will see. Take one more question. This has come in. This is easy question actually. MCQ 1 mark. 21-22 board exam it has come. That time they had term 1 and term 2, remember? Term 1 will have only MCQ and term 2 will have theoretic questions, right? You remember this? During the COVID time. That time this question has come. Simple question, but electric potential is given. They are asking you to find the value of electric field and the coordinates are given as 1, 0, 2. Simple, right? Minus dV by dr. So in this case, only x is there, so there is no yz term also, became more simple. So negative of 6x, and x is how much? 1. So negative 6, it means what is the answer? Option A, obviously 6 along negative x axis. A is the answer. Anybody has doubt in this? Electric field is negative gradient of electric potential. So minus dV by dx if I do, you may ask why not dV by dy, because y term is not there, it will be 0 only, and dV by dz will be 0 only. So dV by dx will become equal to negative of 3 into x square will become 2x, so it will become negative 6x, and x is given as 1 meter. So when you put the value of x1 as, that is x as 1 meter, you will be getting the answer as negative 6. So negative 6 means 6 volt per meter along the negative x axis. Okay, I hope it is clear to you. Is it? Yes. If yes, then let us go to the next. I think next topic will be electric potential due to electric dipole. So in the previous class we learnt about electric field due to electric dipole, where I told you electric field due to electric dipole at an axial point is equal to K into P into 2R divided by R square minus D square the whole square, and electric potential due to electric dipole, electric field to electric dipole at an equatorial point will be K into P by R square plus D square power 3 by 2. In the case of electric potential, the values of electric potential due to electric dipole at an axial point is how much? Anybody remembers? What is the value? V is equal to K Q by R square minus D square, isn't it? Check, this is the derivation. Very simple it is. At this point you will find potential at minus Q, it will become minus KQ by, if this is totally 2D, then it will become half, means it will become D, and this will become D. And from center you will go R distance away. This will become R minus D, it will become R plus D. And when you derive this, you will get the value of potential as KQ by R square minus D square. If R is much more than D, then I can write V is equal to KQ by R square, isn't it? Any problem, Soumya? Yeah, KP, sorry, Q is not there, K into P. Kp by R square minus D square, it will become Kp by R square if it is R being much more than D. And what about equatorial point? This was at axial point. What about equatorial point? Remember? 0. Why 0? Yes, both will be cancelled. Since scalar quantity, there is no vector here. So one will become K into plus Q by root over R square minus D square, R square plus D square. Another will be K into plus Q by root over R square plus D square. Add both will be cancelled. So E will become equal to, not E actually, V. V will become equal to 0, isn't it? So electric potential at equatorial point is 0. Electric potential at axial point is Kp by R square minus D square. This is for axial and equatorial point. If it is random point, dipole minus Q plus Q, angle theta, random point, R distance away. What is the formula? What is the potential here? Y is equal to Kp cos theta by R square. Either you can derive like how I have taught in the class to you, or you can derive like by using cosine rule, your wish. Again, very rarely question comes, but it has come in the past. If it comes, derive it by any way, they will give marks in the board examination. Either cosine rule, more preferable because NCERT gives that, or I told you approximation rule also you can use. In any case, you will get the V as Kp cos theta by R square, and very clearly visible. If theta is equal to 0, it is an axial point, isn't it? Obviously, if theta becomes 0, it will come straight in the line of dipole. And if theta is equal to 90 degree, it will be what? Equatorial point. And for equatorial point, what is the value? 0. And for obviously, put cos 90, it will become 0. And cos 0, it will become Kb by R square. So that way also you can remember. Okay? Is it clear? Any doubt? I hope no. Basic. Tell this question. Fast, simple question. You can immediately say the answer without even solving. It came last year, 2023. Option? Obviously A, isn't it? We know that V is equal to Kp by R square for the axial point, and they are asking for the axial point only. So, it is proportional to 1 by x square. Anybody has doubt in this question? I do not think you should have. The answer is obviously A. Next question, next topic, which I have discussed before some time also. Once again, I will repeat it. Equipotential surface. What is that? It is a surface on which all the points will have same potential. It is a locus made by joining all the points of same potential. So, for example, if I have a plus q charge, you know what is electric field? It will be radially outwards. And if I go x distance away in all the directions, I will have same potential. If I draw a surface, what surface you will get? A spherical surface, am I right? So, for a point charge, what will be the equipotential surface? It will be a spherical surface, concentric spheres. If it is negative charge, electric field is coming towards it, isn't it? So, what will be the equipotential surface? Once again spherical only. Any problem in this? Obviously, it will be spherical only. So, for negative charge or positive charge, the equipotential surface is spherical. What about the, like this, if electric field lines are uniform electric field, what will be the equipotential surface? It will be what? Planes, because the property of equipotential surface says that electric field will always lie perpendicular to the equipotential surface, right. Second rule says that work done to move any charge along equipotential surface is always 0, because potential difference is 0. I hope you are understanding all these things. So, if you have the electric field lines known to you, then easily you can draw the equipotential surface. You should remember for 5 things. One is positive charge, negative charge, one is uniform electric field, dipole and like charges. NCERT gives all the diagrams. For dipoles they have given diagram, for like charges, that is minus minus or plus plus, they have given diagram. They have given diagram for this, that is for uniform electric field, and they have also given diagram for negative or positive charges. You may have questions, they will ask you to draw the EPS. So, do not miss marks there. So, okay, see this question until the answer for this fast. Equipotentials at a large distance from a collection of charges whose total sum is not 0. Planes. Okay. Anybody else? He says plane. Do you agree with him? Spheres. One boy there, Pranitya says sphere, Sanjit says plane. Anybody else? You want to add ellipsoid or paraboloids? What are these? I don't know, sir. Planes. Sphere. Gokul, want to try anything? Sphere. Balan? Don't know. What about you, Tarun? Plane. Soumya? Think and say, right or wrong is secondary, try. You think plane. Since they have told very far, so you think it is a straight line. Why wave optics you are going? Is it wave optics chapter? No, right? See, here the twist was, whose total sum is not 0, isn't it? There may be charges plus q, plus 8q, minus 6q, plus 9q, minus 20q, and if you add it will become 0. No question of having any EPS then. But if their sum is not 0, it means it is behaving like some point charge, isn't it? If you take any point charge, whether it is positive or negative, they are saying sum is not 0. I am taking it as positive value, some q value. What is going to be the EPS? Sphere, isn't it? It will be a large sphere. If they would ask, given the option like large sphere, small sphere, should answer large sphere. But it will be spherical only, because a group of charges together behaves like a single charge. That is why they have given the word large distance. If they would have told plus q minus q nearby, then it forms dipole. Then the electric field lines will not be spheres. Are you getting it? It will have different shape. But if they are telling very far, for very far point, it will behave like a point charge, and for that point charge, the shape will always be spheres. Okay. Next question. Now you can draw this fast. Just now I drawn before some time, right? Minus q, it will be radially inwards. So concentric spheres. Simple it is. It came in 2020 during COVID starting time. This question, give a try. Good question this is. It's a good question. Give a try. A 3 nanocoulomb charge is initially at rest at a distance of 10 centimeter from plus 5 nanocoulomb. Charge Q fixed at the origin. The charge capital Q is moved away from Q to a new position, R2 is equal to 15 centimeter. In this process, work done by the field is how much? Simple question actually. Give a try. Give a try. Give a try, please. Don't give up. Anybody, any answer? Here what they are checking, you know, they are checking your knowledge about potential due to a point charge and work done formula. Because one formula is work done per unit charge, Q naught. One is KQ by R. Q and Q naught are not same. I hope you are knowing this. I can write the formula of V as, for a point charge, V is how much? K into Q by R. At the same time, you can write the value formula of V also as work done per unit charge. Do you think this Q and Q naught are same? No. This Q is the charge of which you are finding the potential. Q naught is the charge that is being moved from one point to another point or from infinite to that point, isn't it? So see properly, you will understand what the question says. Here, a 3 nanocoulomb charge is initially at rest at a distance of R1 10 centimeter from a 5 nanocoulomb charge fixed at origin. It means this 5 nanocoulomb is what? Q. This 3 nanocoulomb is moving. What is that? Q naught. I gave the hint to you. Now what? It is moved away from Q to a new distance 15 centimeter. So they are giving the value of R1, R2 and they are asking you to find the work done. What is the formula of work done? Work done is potential difference by charge which is moved. Potential difference you can easily find. It will become equal to KQ by R. KQ by R1 you have, KQ by R2 you have. Subtract both, get the answer, isn't it? Did you get any answer? Huh. C. Okay, Tarun has got C. Anybody else? Any other answer you are getting? How you have found? KQ by R1 and KQ by R2 you found?
I found potential and minus
You found potential how?
KQ by R.
Okay, for which point? 10 centimeter.
10 and 15.
Both you found and subtracted both and got difference. Very good. What is that? Into Q naught, which is 3 nanocoulomb. Then you got this answer. Then it is correct. I hope you are getting what has to be done in this question. For 5 nanocoulomb charge, for plus 5 nanocoulomb, it means 5 into 10 to the power minus 9 coulomb. This charge, you have to find the potential at which distance? 10 centimeter. Then you have to find the potential at which distance? 15 centimeter. So you got the value of this point as V of A, this point as V of B, and then you will subtract VA minus VB, you will get the value of del V, potential difference, and then multiply, divide potential difference with Q naught 3 nanocoulomb, you will be getting how much is the work done in this process. What happened? Tarun, any problem? V? Okay, sorry. Yes, V into Q only. What I am writing? V Q naught. Because V is only work done by charge. So work done will become equal to V into Q naught. So the value of V is known to you now and Q naught is known to you now. So multiply both, we will get the answer. And the answer will come as negative 4.5 10 to the power minus 7 joule. Check your answer if you are getting this answer or not. I hope you are realizing how the questions can come in the examination. This question, give a try. Again, last year question. Again, a last year question. You may be surprised, no? How in 1 year 3 questions have come from this? This is a, you know how much mark question? It's a 5 mark question, I think. I don't remember, but I think it is either it is a 5 mark question or a 3 mark question. Different papers will have different paper questions, no? You will have set A, set B, set D, like that. So some questions will be in set A, some will be in set B. Don't think from one chapter they are asking 9 mark question, 10 mark question, no, not like that. But definitely this question, this chapter will have 5 to 6 marks weightage. 5 to 6 marks weightage, this chapter. So check. Simple question, but it is a simple question, give a try. Give a try. It's a simple question, I said you. Give a try, fast. Any answer? For the first part you can say, very simple it is. Immediately you can say. Actually without even solving you can say the answer for the first part. Not 0. Actually, I have not talked about electric potential energy till now, right? I have told actually that when I was deriving it, I told you. Electrostatic potential energy formula is what? U is equal to K Q1 Q2 by R. Now here Q1 and Q2 and this is 1 R, then K Q Q by this R and K Q Q by this R. If you realize, you will understand that K Q minus Q by L and K Q plus Q by L will cancel each other. What remains is only K minus Q, Q by L again. So the answer is K Q minus K Q square by L for the first part. Without even touching the pen, I can tell. The first part answer will be electric potential energy U will become equal to negative of K Q square by L. Do you agree with me? What I have done, you are understanding? If you are not, then I have added all 3 possibilities here. U is equal to U1 plus U2 plus U3. U1 will become equal to K Q minus Q by L. U2 will become equal to K Q plus Q by L. And U3 will become equal to K minus Q, Q by L. So in this case, the first and second term will get cancelled and U3 alone will be there, and U3 value is how much? K minus Q into Q will become minus Q square by L. Second part, you got the answer. What is the answer you are getting? Let us check that. So potential at D, how you can find? 3 charge, all 3 will give potential at D. So V at D will become equal to V at D due to A plus V at D due to B plus V at D due to C. Understanding that? So it will become equal to V at D due to A will become equal to KQ by, you want to find this distance, how much will be that? Root over L square plus L by 2 the whole square. How much is that? Anybody has solved? I think it will be root 5 by 2 into L, isn't it? You solve this, how much will we get? L square by 4. So 4L square plus L square will become 5L square. So root 5 L by 2. Yeah, sorry. Minus will come here. Sorry. Minus will come. So if it comes minus, then it will become how much equal to? Root 3, yes. L by 2 the whole square. So it will become L square minus L square by 4, which will become equal to 3L square by 4. So it will become root 3 L by 2, right? So now we have the values. So KQ by root 3 L by 2 plus, what is V dB? K minus Q by root, why root 3 here? L by 2. L and 2 goes above, and plus K into Q by L and 2 will go above, right? Now what we can take common? Common is K, only K we can take. Oh, this will get cancelled, yeah. This will get cancelled. What remains? K 2KQ by root 3L. That is the answer. This question was simple actually. Don't you think so? This question was simple. This question was not like the earlier questions. It is a simple question. This level at least you can happily do. Can I proceed further? Still we are in potential energy. Full capacitance topic is remaining. Shall I go ahead? Take another question. Fast. Consider two identical point charges located at 0, 0 and A, 0. Is there a point on the line joining them at which the electric field is 0? Good question. Two-mark question it was. In the board examination, 2-mark question. Zero, 0, A, 0 means x-axis, isn't it? So distance between the two identical charges is, one is here, identical means one is Q, another is also Q. So this is, I am just writing A between them, so I am writing like this, isn't it? Will there be any point in between the line where the electric field can be 0? Can it be? Yes or no? What do you say? Where? Midpoint, common sense, because if I take the midpoint, that is at point A by 2, then this, if I keep a test charge here, it will be it will be repelled in this direction and in this direction. Cancel each other. So in center point, electric field will be 0, isn't it? I hope you are understanding it. But can electric potential be 0 anywhere in between them? Scalar addition, not vector addition, scalar addition. So KQ by A by 2 plus KQ by A by 2, it will be added. Or any other point you take, A by 3, 3A by 4, or any point you take, it is just algebraic addition, so it can never be 0, because both are identical charges, not minus Q or plus Q. If it is minus Q plus Q, then it can be 0. But both are identical charges, in between them electric potential can never be 0, but electric field can be 0 in the midpoint. Is it clear? Simple question, right? I hope it is clear. Next discussion, give a try fast. Once again, this question was, I think, a part of 5-mark question it is, if I am remembering. Yeah, 5-mark question only it is. 23 paper, some other set. State the significance of negative value of electrostatic potential energy of system. What is the significance of negative value? Anybody can tell? Huh? Yes, attractive. If it is negative, it means that charge are bound together. It will not separate itself. If it is positive, means it will be disintegrated soon. So negative charge implicates that they are under attraction and the charges will be stable. I hope you are understanding this. Negative value of energy always indicates that the force between them is attractive, and if it is attractive, it will be bound with each other. Okay, next part. There are 3 charges, 4 microcoulomb, minus 4 microcoulomb, 2 microcoulomb, and they are asking you to find the electric potential energy. I hope you can find. U is equal to K Q1 Q2 by R. So K into 4 into minus 4 by, what is AV? 2 plus K into 4 into minus plus 2 by 2 plus K into minus 4 into 2 by 2. Just solve it correctly, you will get the answer. Not a big deal. I don't think it is required to be done itself. You can do it later. Are you getting how to do this question? K into 4 in 10 power minus 6 into minus 4 in 10 power minus 6 by 2 plus K into 4 in 10 power minus 6 into 2 in 10 power minus 6 by 2 plus K into minus 4 in 10 power minus 6, 2 in 10 power minus 6 by 2. Just add everything, do proper calculation, you will get the answer. It's a simple 5-mark question or 3-mark question, whatever it may be. Simple question. Any doubt in this? I don't think. It's simple question. Okay, next topic. Electric potential energy of a dipole. So let us we're in electric potential energy only. Okay. So you know very well that if a dipole is placed in the uniform electric field, what it experiences? It experiences a torque. So minus Q plus Q having some angle theta. If it is kept like this, it will always be having a torque which will make it to come parallel to the electric field. Now, if I ask you that this dipole is shifted from theta 1 to a new position theta 2, what will happen? It will get some energy stored inside it. See, initially it was just coming like this. If I give a twist to it, it will come more fastly, isn't it? Because of its energy stored. Something like energy stored in a spring, you can imagine. If you press a spring and release it, will come back. Same way, dipole was there in the electric field. Since electric field was there, it was about to align like this. But if you hold the dipole and make it to go little more angle, what will happen? It will come back more strongly because it has some energy stored inside it. We are talking about that energy only. Electric potential energy of a dipole when it is rotated from theta 1 to theta 2. If you derive it and find, you will get the value of potential energy stored U is equal to, anybody remembers this? It is PE cos theta 1 minus cos theta 2. Never forget this main formula. If we assume theta 1 is equal to 90 degree, why we are taking like that? Because that is the point of maximum torque, isn't it? When theta is 90 degree, tau is equal to P sin theta, sin 90 is 1. So maximum torque is happening at 90 degree. And if you take theta 2 as just theta, then we get the value of U as PE cos theta 1 is cos 90. What is cos 90? 0. Minus cos theta 2 is cos theta. So it will become equal to negative PE cos theta. This is the formula of electric potential energy of a electric dipole. Negative PE cos theta. We have 3 possibilities here. What are the possibilities? Theta being 0, U will become equal to minus P. It is called as what? Stable equilibrium. Remember this, it comes in the examination. If theta is equal to 90 degree, U will become equal to 0. It is called as what equilibrium? Neutral equilibrium. Third case, theta is how much? 180 degree. What will be U? Plus PE. This is called as Unstable equilibrium. Unstable equilibrium. They may ask you for which condition it is stable. We should say when theta is 0 degree and value of u is minus p. Unstable is plus p, theta 180 degree. And neutral is theta 0, u is equal to 0. Theta 90 degree, u is equal to 0. Okay? Is it clear? See the question, how it comes. Solve it fast. Electric dipole consisting of charge plus q and minus q separated by a distance L. Stable equilibrium means what? Minus p. Just tell the answer now, over. Minus q, L, that's all, C. Why they have given third option, you know? Because many children will think 2D, so they will take 2L and mistake will be there. 2D is just for mathematical purpose. They have given here distance between them is L only. Don't take it as 2L. That only you did, eh? Very good. 1 mark you will lose in the board examination if you do like that. 2 is to confuse you. They gave that option also. But the meaning of 2D is distance between the dipole. In this case, they have given L. So, when you multiply the magnitude of charge with distance between them, you get dipole moment. Dipole moment will become equal to Q into L and E. So, minus P E. So, minus Q L E. Got it? Shall we go to the next page? Yes. Now, we are coming to conductors and insulators kept in uniform electric field. I have told this to you when I taught long back. I told that whenever a conductor is placed inside the electric field, what happens to it? What happens? I said conductors are those materials which have free charged particles, right? All the free positively charged particles will start, what will happen? Aligning means it will start moving in the direction of electric field, and all the negatively charged particles will start moving away from electric field. This will generate an electric field in the opposite direction. Can you feel that? It has a name. It is called as electric field polarized, or also called as polarized electric field. And this polarized electric field, since it is for a conductor and conductor has many free charged particles, will be strong enough to cancel the applied electric field. So, inside the conductor, electric field becomes equal to 0. Why it became 0? Since electric field polarized becomes equal to electric field applied. Very important thing. If a conductor is placed inside the electric field inside it becomes 0. This is only called as electrostatic shielding or Faraday's cage also. Faraday's cage or electrostatic shielding is the property of conductors to have 0 electric field when placed inside uniform electric field. Another thing is the behavior of insulators. It is very strange to know that when a insulator is placed in the uniform electric field, then insulator means what? It will have less charged particle, not 0 charged particle. Less means a few of positive charge will come here, a few of negative will come here. Here also we will have a polarized electric field, but this polarized electric field will not be strong enough to cancel the applied electric field. So, electric field will not be 0 and its value will become equal to E applied minus E polarized. So, when a conductor is placed inside uniform electric field, it has 0 electric field, but when an insulator is placed inside uniform electric field, it has some electric field left inside it. That property of the insulators only we use it in the capacitors. It is called as dielectrics. Insulators are also called as dielectrics. We will talk about that. Is it clear to you? The behavior of conductor and insulator? Okay. Next, take one question, very basic question. Give a try. Good question. Last year it came, 2024 paper it is there. Last time is this year only, the people who wrote the board exam. This year means your seniors obviously. March when they wrote, no? This year. Any answer? Option? D. Okay, he says option D. Anybody else? Sanjeet says option D. Anybody else? A. Okay, he says A for Aditya. Sanjeet, what do you say? D or A? A. Okay. Now the answer is A. Others? A. What happened? Everybody agrees to A. Say if you have something else. You cannot solve this question. You should understand this question. What, Tarun? Agree with A? No. Then? Don't know means only 4 options are there. Choose one thing. No negative marking. It is not JEE exam. B. Or you will choose B. You will choose C. Okay. A, B, C, everything, huh? A you will choose. Okay. A is not the answer. Huh? D. Okay. Inky Pinky you are doing and something which you are getting, you are selecting it, isn't it? Mr. Siva Prakash. Girls, giving up. Soumya, try, right or wrong, who is going to give any prize or any punishment? Nothing is going to happen to you. Give a try. Nothing works. Try your luck. C, B, D, what? Okay, let me not waste time now. Please pay attention. There is an isolated conductor and they have told that this conductor has a cavity. One thing they told, net charge is plus Q. What is the meaning of net charge? Total charge. And they are asking to you, what is the charge on the cavity wall and the charge on the outer surface? One more thing they told you, that a point charge plus Q is inside the cavity. If a charge of plus Q is inside the cavity, by induction, it will produce a negative Q charge here. Do you agree? And a plus Q charge here by induction. That is, all the negative charge of this will be coming towards it, positive will go away from it. Right? Now, what they are asking? First is, what is the charge on the cavity wall? This is only cavity wall. What is the charge? Minus Q. So, answer can be either B or C. A and D is eliminated. Okay. So, on the cavity wall we got minus Q. Next is at the outer surface. So, outer surface is having plus Q, we know. And net charge is how much? Plus Q. So, what is the charge on the outer surface? How can you find that? It will become equal to net charge minus what is charge present? Plus Q. How much will be that? Q minus Q. What is the answer? You told answer B, I think. Tarun told. Who told answer B? There you told. You told answer B. C. C you told. Got it? Sometimes you have to think for some questions a bit. Next, we don't have much time. Please pay attention. Capacitance and principle and its principle. So I told you, capacitor is an electrical device which is used to store energy. And how it stores energy? By storing charge. So if you push some charge inside the capacitor, inside a conductor, it becomes charged, and whatever work you are doing to send a charge inside the capacitor, that work is only stored as a charge of the electric energy of the capacitor. Are you getting my point? So if I send another positive, then it will be having a repulsive force. Some work has to be done to send it inside. the work that you are doing to send the charge inside this conductor, that work only is stored as what? The energy of the capacitor. Then I said you that when it starts becoming positively charged, then it will become a huge positive charge and the nearby medium will start to get ionized. For example, if I am assuming outside is air, what will happen? Air, all the negative charge of the air will be attracted by this positive charge, neutralizing negative and positive. So, air will start becoming positively charged. It is called as ionization of space. And for air, what is the breakdown voltage? It is actually 3 into 10 to the power minus 6. Check the NCERT book, something like this, volt per meter. This is the maximum electric field which can be taken by this insulating medium before undergoing breakdown. What is the meaning of breakdown? After a certain value of this potential, it starts ionizing the medium around it. That phenomena is called as ionization of the space around the capacitor. And when ionization is happening, understand that capacitor has become full. Are you getting? Because if it is not full, this will not happen. It is becoming that much strong, it starts breaking the, what do you say, the charges around it, along its way. Now the thing is, one positive charge is taking out one negative charge from here, so one positive charge is coming outside. In a way, I am creating a space for positive to go inside now, because this got neutralized, isn't it? So one positive can once again go inside. When positive came inside, once again one positive can go and ionize the next air molecule. It means that there is some kind of leakage of charge happening, not directly, indirectly. If in the board exam they ask you, what do you mean by leakage of charge of conductor, capacitor, what will you write? At breakdown voltage, the capacitor starts ionizing the medium around side. It's not like literally leaking. It is like, since one negative is ionized by one positive becomes extra here. So we are giving one positive inside this. So this phenomenon is called as leakage of charges. And this strength of the medium is also called as dielectric strength. Dielectric strength is the maximum electric field which the insulating medium can withstand before undergoing breakdown. Is it clear to you? We know that Q is proportional to V. So Q will become equal to CV, C will become equal to Q by V. Q is in coulombs, V is in volt. Coulomb per volt is called as what? Farad. Farad is the SI unit of capacitance. I hope you are understanding. A capacitor is just a device which is having charge stored in it. It need not to have parallel plates always. Just a single plate also can be a capacitor. If you bring a parallel plate near to it, its capacitance will increase because the potential reduces. Understand that if you have like this a positively charged plate and in front of it if I bring a neutral plate, the neutral plate will have induction negative charge here and positive charge away from it, isn't it? So by this what will happen, if this, suppose the potential of this surface was 100 volt and this becomes minus 80 volt and this becomes plus 60 volt, add all these things, 100 minus 80 plus 60, how much you will get? 80. So from 100 it reduced to 80, potential got reduced, capacitance will get increased. That's why we bring an uncharged plate in front of a charged plate. It reduces the potential, increasing the capacitance. If I further do earthing of this plate, what will happen? This plus 60 also will go inside the earth. 100 minus 80 will become how much? 20. Further reduce the potential, further the capacitance increased. So just an isolated plate also is a capacitor. If you bring uncharged plate in front of it, its capacitance increases. If you make the uncharged plate earthen, its capacitance further increases. And what is the capacitance of a parallel plate capacitor? You know the formula? Okay, before that, spherical capacitor. What is the capacitance of a isolated spherical capacitor, not parallel, isolated? Any idea? The formula you know? C is equal to 4 pi epsilon naught r. Don't forget this. How it has come, you know? C is equal to Q by V. For a spherical shell, we know that P is equal to KQ by R. So, QQ gets cancelled. C will become equal to R by K. What is K? 1 by 4 pi epsilon naught. So, C became equal to 4 pi epsilon naught R. This gives us an idea how big is 1 farad capacitance, because if I put the value of C as 1, 1 will become equal to 1 by 4 pi epsilon naught R, and R will become equal to 1 by 4 pi epsilon naught. Its value is 9 10 power 9 meters. To hold 1 farad capacitance, we need a capacitor of radius 9 into 10 to the power 9 meters, which is almost 1000 times bigger than the earth size. That's why 1 farad is a very huge value, and we take smaller values of farad, which is microfarad or nanofarad or picofarad. So, practical values of capacitance are nano, pico, micro, because 1 farad is too huge value. What is the capacitance of parallel plate capacitor? You remember this? C is equal to epsilon naught A by D minus T plus T by K. Should remember this formula, main formula. If you remember this, you can find anything else. This is the parallel plate capacitor with dielectric inside it, and dielectric not fully filled also, because if it becomes fully filled, for fully filled, what will be the value of T? T will become equal to D. Put here, C will become equal to D, D will get cancelled, it will become dielectric constant times epsilon naught A by D. Do you agree? And if it is no dielectric, that is, if T is equal to 0, it means what? No dielectric. If dielectric is not there, then T is 0, C will become equal to epsilon naught A by D. So, parallel plate capacitors capacitance is epsilon naught A by D for what? For no dielectric. K into epsilon naught A by D for fully filled dielectric, and epsilon naught A by D minus T plus T by K for partially filled dielectric. I hope you know that D is the distance between the plates and T is the thickness of the dielectric. If I am having thickness as T, this is T. If T becomes D, it becomes fully filled dielectric. If T is 0, it means it is having no dielectric. So, for all the cases, we have the value of capacitance. If you know this formula, derivation is also important. In the board examination, this derivation also comes. Please go through that also. So, if I go to the next page, let us take the question which has come in the board examination. The first part I don't know it of doing now. The same thing I told you. In the board exam, they may ask you, obtain the expression for capacitance of a parallel plate capacitor with dielectric medium between its plates. You can solve it. Second part you solve now, fast. This question is actually not from this topic. It is from electric potential due to a charged spherical shell. KQ by R you will do, you will get the answer. Anyhow, simple question. This you can solve, later also you can solve. Next we will go. Capacitors in series and parallel. So, I have said to you during the regular class earlier, if the capacitors are connected in such a way that one plate, that is if this is plus, minus, plus, minus, plus, minus, then you get a series connection. In series connection, what remains same? What remains same and what changes? Voltage remains same. Changes. It becomes V1, V2 and V3. What remains same then? Charge remains same. Q remains same. So, if you do net V, it will become equal to V1 plus V2 plus V3, and V is equal to what by what? Q by C. So, you will write Q by C is equal to Q by C1 plus Q by C2, and finally you will get C is equal to 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3 and so on. This is for series connection. If it becomes parallel connection, then all the positive plates are together and all the negative plates are together. In this case, what remains same? Voltage remains same and charge gets divided. Q1 here, Q2 here and Q3 here. So when you do Q is equal to Q1 plus Q2 plus Q3, Q is equal to CV. So finally you will get C parallel is equal to C1 plus C2 plus C3. Exactly ulta of resistance, isn't it? So in the case of series connection, here it will be 1 by C series is equal to 1 by C1 plus 1 by C2 plus 1 by C3, and parallel connection, C parallel is equal to C1 plus C2 plus C3, right? Next question, 5-mark question in the board examination. 5-mark question again. No, sorry, it's MCQ, 1-mark question. Next one only is a 5-mark question. It's a 1-mark MCQ. Give a try, fast. Option A, all three in parallel. 4, 4, 4 in parallel, net will become equal to how much, man? 6 it will become. If all three are in parallel, then 4 plus 4 plus 4, it will become 12, no? C you are saying. Ponayata says C. Whether C is correct? 4 and 4 in series, it will become 4 into 4, 16 by 4 plus 4 is 8, so it will become 2. And then 2 and 4 in parallel, 6. Good. C is correct. C is correct. I hope you are getting how C. If 4 and 4 are in series, it will become 1 by 4 plus 1 by 4 is equal to 1 by C. So 2 by 4 will become 1 by 2. So CS will become 2. 2 and 4 are in parallel, you will add them. 2 plus 4 will become 6, isn't it, Gokul? Understood? Simple question, isn't it? Next. This also one topic is there. Polar and non-polar molecules. I told you, what is the meaning of polar molecules? Materials which have dipole moment inside them are called as polar molecules. For example, HCl. Their positive center and negative center are separated by some distance. So they become a dipole. Take hydrogen H2 or N2 or O2. They are non-polar because their negative and positive centers lie at the same point. So I told you, if you have a material which is made up of polar molecules, then it will have dipole moment. If I represent dipole moment by this arrow, they will be randomly oriented. So the net dipole moment still will be 0 only. If I take a polar molecule on an individual level, that is one polar molecule, it will have dipole moment. But if I take a material made up of polar molecules, dipole moment will be 0 only. Why 0? Why 0? Because the net dipole moment will be cancelling each other, they are randomly oriented. But if you have a non-polar molecule, dipole moment will be still 0 because they don't have any dipoles itself. No dipoles. Dipole moment 0 whether it is a polar molecule or it is a non-polar molecule. This is for a polar molecule. Like example HCl. This is for a non-polar molecule. Example H2, N2, O2, anything. So whether it is a non-polar molecule substance or a polar molecule substance, it will not have any net dipole moment. But the moment you are providing some what? Electric field to it. You know what will happen now? The polar molecules start aligning in the direction of electric field, and so now they will have a net dipole moment which will not be 0. And even in this case, there was no dipole. But now because of electric field application, the positive will start going towards electric field, negative will go away from electric field, there will be some kind of dipole forms. Here also dipole moment will not be 0. Very strange, you know. Whether it is polar molecule or non-polar molecule, They will not have any net dipole moment when they are not subjected to any electric field. And whether it is polar molecule or non-polar molecule, they both will get dipole moment when they are subjected to external electric field. Difference is, it will have a stronger dipole moment, it will have a weaker dipole moment, but it will have some dipole moment. This net dipole moment per unit volume is called as what? Net dipole moment per unit volume is called as what? Anybody? Net dipole moment per unit volume is called as polarization vector. You forgot this. Polarization vector is called as net dipole moment what? Per unit volume. What will be its unit then? Unit will become equal to coulomb meter divided by meter cube, which will become equal to coulomb by meter square. Which other quantity has same unit as polarization? This is coming in the board examination. Which other quantity has same unit as polarization vector? Surface charge density, good, because it is Q by area, isn't it? So sigma and P, they have same units, remember this, which is coulomb per meter square. And this polarization vector is proportional to what? Electric field vector. More electric field, more polarization. Less electric field, less polarization. So I will remove this polarization and I will add one constant. That constant is called as electrical, I have written magnetic here, wrong. It is electrical susceptibility, chi E. Electrical susceptibility, chi E. So how do you define this chi E? Chi E is defined as polarization per unit electric field, isn't it? Polarization vector per unit electric field vector is called as electrical susceptibility. It is E. Okay. Electrical susceptibility is defined as polarization vector per unit electric field. Questions will come from here also. Are you getting my point? Okay. Now coming to some questions from here. One story is given. It's a which question? Case study type question. It came I think last year. See the first question. Which of the following is polar molecule? 1 mark easily came. Second question. Which of the following statements about dielectrics is correct? Read properly and say. A, B, C or D. They are asking which is correct. That means 3 are wrong. The first one is wrong or correct? Option D correct. Think here. Surface charge. No. B is correct. Net dipole moment of induced dipole is along direction of applied electric field, obviously. Isn't it? What, Sanjeev? Third question. The same. Good question this is. D. So energy is increasing, electric field is reducing. A. Energy is increasing, electric field is also increasing. I told you for some time, when you keep a dielectric inside the conductor, its electric field will be reduced, I told no? It will become E applied minus E polarized. So one thing is very sure, electric field is going to decrease. So option can be only B and D. Is it clear? Now energy will also reduce or energy will increase? Increase. Why? Because that's why we are using dielectric to increase the energy. You are thinking like that, no? No. Huh? B is correct. Energy will also reduce. If you want to know why, we will discuss it. Energy will decrease as well as electric field. Remember these things. Question comes in the board examination. Whenever a dielectric is placed inside the capacitor, parallel plate capacitor, its energy reduces. What increases? You know, one thing increases. Capacitance alone increases K times. Okay, let me ask this question to you. You may ask why, right, Tarun? What is the formula of energy stored in the capacitor? U. U is equal to half CV square. Half CV square is for the condition if C and V are constant. We have another formula, Q square by 2C, isn't it? Where is this formula? And what is the value of C for dielectric medium? C is equal to what? C is equal to K into epsilon naught A by D. Do you agree? Epsilon naught A by D is what? It is the capacitance of the capacitor, not without dielectric. So can I write U is equal to Q square. Let this formula be there. Why I am writing that? U is equal to Q square D by 2K epsilon naught A. Now tell me, dielectric introduction is increasing or reducing? Are you able to feel it? Reducing. So always remember that whenever a dielectric is introduced inside inside the capacitor, electric field reduces, electric potential reduces, capacitance increases, energy stored also reduces. This question has come multiple times in the board examination. The same question. Next question. Solve this question. You have to solve it only. Air filled capacitor plate A and plate separation D has capacitance C naught. Slab of K, area A, thickness D by 5 is introduced. What is the capacitance? Solve and get the answer. C is equal to epsilon naught A by D minus T plus T by K. T is given as D by 5. Solve and get the answer. Simple question. Solve it and get the answer fast. The formula C is equal to epsilon naught A by D minus T plus T by K. If you solve using this formula, you will get the answer. Epsilon naught A by T plus T by K. D minus T plus T by K, where T is thickness and small d is distance between the plates. Make it fast. Any answer? Any answer? Still solving. C is equal to epsilon naught A by D minus D by 5 plus by K will come here only, isn't it? So what is going to be common? D will be common below, right? If it is D is common, what will be remaining here? 1 minus 1 by 5 plus 1 by 5 K. And this epsilon naught A by D will be C naught, isn't it? Let us see here. C naught divided by what I am doing LCM 5K. Can I tell like that? So it will become how much? 5K plus K plus 1. Can I write like this? Actually minus K. Here minus will come. Divided by 4K plus 1 and 5K will go above. What is the answer? I hope you have understood this. C is the answer. Is it clear to you? See, this is how the questions are being asked in the board examination. Please pay attention. Whatever questions I have taken today was all from last 3-4 years of the board papers. So initially you would have felt it was little tough. That is the reality also. From this chapter in the board, question can trouble you sometimes, even though if you are very strong in the subject. So please go and look into all this charge, is distribution of charge, when two are connected, what will happen to it, these things, go through it. Fine. Same way, like how we did in today's class, next class we will take the previous year questions from current electricity. So, every Monday we are taking a subject and taking a chapter, and we are doing its all previous year questions and a quick revision. I am not doing revision in detail because we do not have time for that. I am doing quick revision and doing all the past papers. I am focusing more on solving the past questions to give you an idea about how the questions are coming. Okay. If everything is fine, then you can drop off. Yuvan, Yuvanesh, Vishwajit, we can start moving. Take care. Bye bye. We will meet again in the next class.